My name is Vint Cerf. I'm Google's chief internet evangelist, and today we are launching IP version 6. Over 20 years ago, it was understood that we were going to run out of IPv4 address space someday, and in a panic, a collection of us worked on IP Next Generation, which ultimately became IP version 6. It was standardized in 1996, and for all practical purposes, almost no one implemented it. But then, in February of last year, the Internet Corporation for Assigned Names and Numbers and its Internet Assigned Numbers Authority ran out of IP version 4 address space to hand out to the regional Internet registries, who in turn hand address space out to the Internet service providers. So the consequence of that is that many of us have been working very, very hard to implement IPv6 in parallel with IPv4. For those of you that are mathematically inclined, you know that the IPv4 address space is 32 bits long, accounting for 4.3 billion addresses, somewhat augmented by what is called private IP address space and devices called network address translation boxes, which effectively get in the way and reuse IPv4 addresses, allowing people to share them in local networks, for example. But that's not the original way the Internet was designed. It was designed to operate end-to-end with identifiable endpoints that were unique. IP version 6 has 128 bits of address space. That's enough for 3.4 times 10 to the 38th addresses, 340 trillion addresses, a number that only members of Parliament and members of Congress can fully appreciate. Today, we are launching IP version 6, and we're leaving it on. We tried this last year around the same time for one day, 24 hours. The test went well. There were no major disasters, but lots and lots of people still had work to do to make version 4 and version 6 run in parallel. So today is really the launch of the 21st century Internet with this much larger address space. I remind you that we're not switching over. This is not like a big flag day. What this really is turning on an additional and much, much larger address space so that we'll be able to grow the Internet well beyond its current confines. This is going to be very important for several reasons, not the least of which is that mobiles today number about 5.5 billion, which is clearly more than even the version 4 address space could support. Moreover, an Internet of Things is on its way. The Smart Grid program in the United States and in other parts of the world will bring new appliances, devices, even light bulbs to the Internet world. And we're going to need lots and lots of address space to do that. We're very, very pleased to be part of the IPv6 launch sponsored by the Internet Society. There are literally hundreds of us, even thousands of us, who are participating today, turning on IPv6 on the application side, on the ISP side, and in many cases, people already have V6 capability in their edge devices, whether it's laptops or desktops or servers. It's just that the Internet service providers have only recently managed to turn everything on. So I am joined today by some extraordinary people who have really made this IPv6 happen, certainly here at Google, at Comcast, and Cisco. Lorenzo, Khalidi, and Eric Kleiner from Google, would you wave to the audience and say hello, please? Can you say hello? Yes, we want your voices.
My name is Lorenzo Khalidi. I'm my somewhat tongue-in-cheek title at Google is IPv6 Samurai, in memory of Itagen, the original IPv6 Samurai. I've been with the IPv6 project since the very beginning, together with Eric, focusing mostly on the network and infrastructure side. And it's really exciting to see 5 years of work coming to fruition, if you will. We've been with the project since the very beginning.
Yeah, it's been a long time. It's been 5 years since just after we lost Itagen. I'm Eric Klein. I work on IPv6 software engineering, trying to make our whole networking infrastructure stack support IPv6. So,
thank you both. John Brewski, are you here also from Comcast? Could you wave to our listening audience and introduce yourself?
Hello, Vint. How are you? Hello, my name is John Brewski. I work for Comcast. I've been running the V6 program at Comcast for approaching 7 years now.
Wow.
So it's been a very long road to hoe. So a lot of personal and professional milestones that we're reaching here this year. The work at Comcast has taken us everything from running the core of our network, all of our applications, and expanding that out to to things that are subscriber-facing, like our internet services, including broadband content and other related applications.
Thank you very much, John, not only for that nice introduction, but for 7 years of work. Marc Townsley is also with us from Cisco. Marc, would you introduce yourself as well, please?
Hello, everyone. Hi, Vint. My name is Marc Townsley. I'm a fellow at Cisco. I've been at the company here for 15 years. I haven't been working on IPv6 that entire time. I started working focusing on v6 during a period between 2005 and 2009 when I was serving as area director in the IETF, and that's when I met guys like Eric and Lorenzo and John, etc. And it's really been great working together, working with all of our, being a network vendor, I work with so many different facets of this, and I've made a lot of friends, and yeah, it's been a fun ride. I really look forward to the next few hours from now when everything flips on.
Well, I think Marc, it's going to be the next 3 decades that we're all looking forward to as this network explodes underneath us. We also have with us Stephen Shanklin, who's here from CNET, and will be asking questions along with me in the course of this conversation. Stephen, would you like to introduce yourself, please?
Yeah, sure. My name is Stephen Shanklin. I'm a senior staff writer with CNET News, and I don't have anything like the technical chops anybody else on the line here does, but it's my job to chronicle the history as it happens. So I'm very excited by this transition we're going through. Obviously, it's a very long process, but it seems like tomorrow's going to be a pretty big milestone. So thanks for having me on.
Well, we're delighted to have you, Stephen, and we look forward to the questions that you have for our distinguished guests. Let me just start out by asking all of you to respond to the question, why is it that we have to have IPv6? I mean, what's wrong with NAT boxes and sort of reusing IPv4 address space? Wasn't that enough? And how come we're working so hard on IPv6? I don't have this directed at you. Just jump in if you have a response. Lorenzo, the samurai.
I think this is Eric's call, right? He's the application developer, right? He suffers the complexity.
Yeah, I mean the complexity that is introduced by NAT is tricky. It means that you can't just write an application anymore and have 2 devices talk to each other. And in order to continue to scale the internet, there will then be there are in fact now in some places 2 or more layers of NAT, and this is extra impossible to make 2 devices try to pass packets back and forth. It means that packets have to go out one NAT and then hairpin in off another NAT to talk to a neighbor if you want to try to make such connections. And that makes things like video chat actually really, really difficult. And it means that a Hangout like this, we have to, and video chat, we have to relay more and more traffic. So as an application developer, it's fairly painful. And also it means that you know, people like to write applications that pull data down from the web, and want to have several simultaneous downloads going. You want to have all of your music downloading from your favorite download site, and you also want to simultaneously be uploading things to your cloud so you can download it to all of your mobile devices. And every single one of those connections would need to go through yet another NAT. And if you run out of ports, then your connection to the internet is toast. That's it. You have to share your own bandwidth with all of your neighbors and all of your neighbors' neighbors. And not just the bandwidth needs to be shared, but the reputation that goes with that needs to be shared. If one of your neighbors decides to be a spammer, then the entire neighborhood could be misclassified.
So, Eric, thank you. I want to get to Marc also and to John. One of the questions that comes up is machine-to-machine interactions, which the Internet of Things sort of draws our attention to. Won't this be easier with IPv6 than it would be with the various NAT structure that Eric described, which sounds to me like it would be rather fragile and brittle, to say nothing of having potential bandwidth problems? So, Marc, would you agree with that, or do you have another slant on it?
So I agree with it. I want to add a little color to it. As someone who has to build this network gear, we ultimately want to create a network that allows for the most rapid innovation, and in order to do that, we need easy connectivity. The NATs that Eric was talking about, we can build those things, right? But we only have a certain amount of cycles and a certain number of engineers to work on things. I would much rather trade those cycles and those engineers towards other kinds of things for the network to do than just this simple kind of connectivity, stateful connectivity within the network. We want that state out of the network like your original design. We don't want to go back to the 60s when we had like big, huge circuit switches everywhere through the network, and that's what these NATs look like. We can build them, and we get a lot of pressure from people to build them, but what we would rather spend our time on is all the other things that we're asked to do, and get out of the business of creating NATs and back into the business of bigger and bigger IP networks that are easier to operate, easier for application developers. And that's why we're actively trying to steer people in that direction.
So, John, you're on the other end of this picture. You're trying to provide services to a large number of people. What's your take on this question?
So, Vint, the take from our point of view has, from the very beginning, almost 7 years ago, has been business continuity, right? I mean, Comcast is one of the largest service providers in the world. So, from our point of view, the idea of having to, federate IPv4 address space, whether it was, private or public or what have you, it wasn't a scalable long-term solution. So, for us, one of the very early drivers was business continuity, and then, of course, we used that as a foundation to expand the program. And then, of course, provide a platform for innovation, right? So for us, we feel that that this helps to brighten the future as far as the innovative opportunities are concerned.
That's a very good point. Stephen, you might have some questions you'd like to ask of this distinguished group. What would you like to put on the table now?
Yes, well, since I've been writing about this recently, one of the questions I get pretty often from readers is, we have a lot of technically savvy readers. How do I get on board? How do I jump into IPv6? So, I mean, what's your advice? Maybe this is a good question for perhaps for John. I'm not sure exactly who the best is to start, but what's the first step people should do if they want to actually, sign up? Should they just test their machine at some site? Should they call their ISP? What should they do?
So what we've done, Stephen, is we've basically taken the approach where we enable it by default for folks wherever we've launched IPv6. We've tried to provide as much information as possible to our subscriber base to make sure that you can assess what your capabilities are, based on where we've launched, including your modem capabilities and as well as your home networking device capabilities. I won't go too far into the home networking piece. Perhaps that's an area that Marc can elaborate on a bit. But from our point of view, we felt that if you wait for people to ask for IPv6, we'll all be sitting here about a decade from now still waiting for that first phone call. So we've taken the approach of we're going to turn it on. And I think my friends and colleagues here, at least in some way, shape, or form, whether it's indirectly through parents or personally, have experienced how we've done at that endeavor.
So I'm going to jump in for just a second. It's Vint, and just point out that no user should have to ask for IPv6. They shouldn't even know what it is, frankly. They should just be able to use the network, and all that addressing stuff should go on under the covers, and no one should notice. If we're waiting for them to know that, that's the wrong thing. Okay, who did I interrupt?
That was me again. I guess that's just a question for the the early adopters, the enthusiasts. I suspect probably a sizable fraction of the audience watching this falls into that category. So I wanted to make sure we had that addressed. Another big question though is how ready is the average person for IPv6? What fraction of people's personal computers out there, mobile phones, are actually ready to get on IPv6 today?
So who wants to go ahead, Lorenzo?
Parents are on IPv6 already, right, Eric?
Yeah. So if you plug in directly to your provider, you probably are running an operating system that is IPv6 capable. But if you have a home gateway, you're in a much more problematic situation. Only recently have we got commercial availability for home gateways that support IPv6, and D-Link and Linksys and other participants in the home router vendor category on the participant list have made that possible. And in my own particular case, for my parents who live here in the Bay Area, they have Comcast, and when John told me that they had turned it on in the Bay Area, I had to go replace my CPE. So I went down to Fry's, I bought a CPE, and I have been streaming Netflix over V6 to my parents' house. And that's something that we've really, I think this whole event collectively has managed to create a kind of necessary advantage for providers, the reward for providers, right? Netflix streaming bandwidth is, by some estimations, what, 30 to 40% of backbone traffic in the U.S. YouTube, another, 10% on top of that.
Yeah, but to get back to the question is
So-
about users, right? What
Right,
do they
so
want to
a
do?
properly enabled user can have more than half their traffic switch, but finding them is, getting them enabled is a last mile issue.
So from
So
an
the-
operator,
So, Mark,
Go ahead.
so from an operator's point of view, somebody who sees this almost on a daily basis for the past many years, Stephen, to answer your question specifically, we're seeing about 5% where we've launched having the ability to support V6 out of the box. To kind of echo what Eric had alluded to a moment ago, a great many of those people are folks who take their computer and directly connect it to a cable modem. However, one of the things that we've seen in recent weeks and months is that there is a growing population, perhaps 20 to 25% of that user base, that is actually using home networking equipment, which is a non-trivial number. We still have a long way to go, but it's a real number.
So Mark, maybe you can speak to this because Cisco makes equipment that goes out at the edge,
Right.
setting aside the question of laptops and desktops and printers and other appliances. How does it look from your point of view?
So one of the very important parts of the World IPv6 launch this time, there were basically 3 categories, and one of the categories was home networking equipment. And what we wanted to do there is improve the implementations that existed out there, because there were a number of products that you could find if you looked for them, and if you knew how to go in and configure them, if you're one of the enthusiasts that Stephen was referring to, you could go figure it out and kind of make it work, right? But it wasn't mainstream. It wasn't fully supported. And one of the requirements was that IPv6 be enabled by default on the box, because your average consumer is very different than an enterprise router, but your average consumer is just not going to go in and start clicking all those buttons to get IPv6, right? It needs to be there by default, and it needs to be supported to the level that the user doesn't turn around and take the equipment back to the shop that they bought it from when it doesn't work, right? So it was a lot of work to actually take what the IPv6 implementations that were out there for a very long time and make them fully production ready and make them enabled by default and go through the quality control to allow them to be enabled by default for a consumer that doesn't know how to tweak things and it's hard to get feedback from. We've done that. And so all of the E-Series, EA Series, all of our new line, if it's being phased out, it's not going to be on the store shelves. But all of our new routers have IPv6 enabled by default from the lowest end to the highest end.
I had a question for Lorenzo. Maybe you could come in from the other side of the equation, from the perspective of a business who has a company to run on the internet. How expensive is it to add IPv6 to your operations? Obviously, for a company like Google, it's got to be very complex. But how hard is it? You can't just flip a switch and install a router. It's more complicated.
So it's Vint. I'd like to get 2 answers to that question. One coming from Comcast and one coming from Google. Lorenzo, I think you were beginning to respond.
Yeah, so, well, I mean, from our perspective, you're looking at 2/3 of the IPv6 team right here, right? It's not a huge undertaking. It's the kind of undertaking that's difficult to do in a big and complex organization because it's very wide and not very deep. So it touches a lot of pieces that are in lots of different groups. So it's more of an organizational challenge than a technical challenge. As regards, the actual economics of the thing, it doesn't have to be expensive because, thanks to, partly to the fact that IPv6 has been defined for such a long time, the implementations are mostly actually there. So in most cases, you don't have to buy new gear to support IPv6. You have to configure it appropriately, perhaps do a firmware upgrade to make sure that the 99% implementation gets the 100% implementation. But it's really not, it's wide and complex, but it's not expensive.
So just looking at this from my somewhat distant perspective, watching our Samurai at work, one thing I would say is it's incredibly painstaking because every piece of code that knows anything about an IP address suddenly has to know there's two formats, and it has to not get confused about that, and it has to be able to use both at the same time. So what about Comcast, John? How did that go for you?
Yeah, so Vint, I mean, we, you know, while I represented probably 99% of the team for the longest time, you know, over the past recent years, you know, through kind of, very long-standing support from my management executives, we now have hundreds, if not thousands, of people who participate in the rollout of V6 on a daily basis. You know, can't thank those folks enough for all the work. We had a slightly different situation. In addition to some of the organizational challenges, we also had technology to specify, right? So DOCSIS 3.0 is where the cable industry had introduced support for V6, and 7 years ago, that's where we started. We started defining the technology. So in addition to the items that Lorenzo had mentioned, as far as, you know, making sure that, you know, we get, you know, gear in the network, configs, test the software, et cetera, as far as core networking equipment is concerned, we had the extra couple of steps to include not only the DOCSIS layer of the network, but also how that interfaces with our subscribers, which is a very diverse environment.
So, Stephen, I want to come back to you for a minute and ask whether we could explore what it looks like from the user's point of view. What happens if there's a problem? Where do I go? What do I do? And the other one is, what does it look like from the standpoint of operations? Because it's not just a matter of software and equipment. It's also actually being able to run a network where you have both protocols at the same time. Were those questions that in the kit bag that you might be willing to pursue?
Well, you know, I think that I've run into a lot of different answers on, you know, what to do. I think the most helpful sites I've seen so far are just the basic guides. I think Yahoo has a pretty good one on its help page that you can reach through the World IPv6 launch site. So, you know, I think we're starting to get to the point where there's some explanation out there on the internet, but I'm running into still quite a lot of confusion. A lot of people don't know what it is, don't know whether they need to care, what to do. So, you know, I think there's still a lot of marketing work that has to be done by people such as yourselves. But you know, I think the publicity that's coming up with the IPv6 day last year and now the launch this year, it's certainly going a long way to increasing awareness. Clearly, it's a multi-year process to actually make the switch, but you know, obviously the only way it's really going to happen is when it's just enabled by default with everything that people buy, and that's going to be the solution.
So, Stephen, I would like to suggest a vocabulary change, if you don't mind, especially given that your visibility in the community. I would say this is not a switch. This is adding a capability to the network, and people who imagine that it's a switch won't actually appreciate what's going on. What's really going on is that we're going to allow the edge devices to communicate with both protocols at the same time if need be. So I would beg you to use that descriptor as opposed to switch.
Yeah, it's clearly a milestone in a long journey here. One thing I was specifically curious, maybe Eric could answer this. You know, we've been talking a lot about the stick here, you know, the pain that you guys had to go through to make the transition to get your own businesses ready. But what's the carrot? Can you give some examples of, you know, interesting things you could do when you have this end-to-end connectivity where you can get a direct peer-to-peer connection between, you know, my mobile phone and some web server, or my phone and my refrigerator at home or something? Can you give some examples of what's easier to do once you have a direct IPv6 connection?
Sure. Well, obviously, voice and video chat are easier to do. The Google Talk plugin has video chat support in beta at the moment, and we've tested that on the network, IPv6 network in Japan, and it syncs up fast and just fine. And it doesn't have to go through any of the rendezvous protocols to find each other. It just passes the address that they want to talk to, and 2 or 3 packets later, the connection is flowing. So it actually works pretty well. I think the real killer application is that we get to continue to use the internet the way we have always used the internet, and it's not just the web anymore. Before there was sufficient deployment of IPv4, there wasn't a web. People need to remember that there was an internet before the World Wide Web came along, and it wasn't until there was a critical mass of internet connectivity that someone was able to come up with this thing that basically now powers economies around the world.
So, Eric, this is Vint again. One observation I would make, and then we'll come to Marc, is that when you use V6, or when you use V4 on an end-to-end basis, you have the opportunity to initiate a connection to the other side, as opposed to, as you say, Eric, having to go through funny rendezvous protocols in order to discover what somebody's public IP address is. This brings us to the point where IP is now comparable in many ways to the kind of initiated connectivity that you get with the telephone when you make a call to another party, or send something to a printer, or send something to a fax machine. It's the ability to do direct connection that will create a new platform for all kinds of applications that would otherwise not work very well. Marc, you were going to jump in.
So I'll take what you said and just keep going with it a little bit and say that the end-to-end connectivity, I like to think of it as you won't have, we hear a lot about the cloud and connecting to the cloud, et cetera, right? I think sometimes we connect to the cloud because we can't connect to anything else. It's so hard to just connect to some other device out there, we give up and we go off and connect to the cloud and put everything in the cloud. And I think that shift, when IPv6 is deployed to the level that it becomes that platform, it shifts back. And we become part of the cloud rather than just connecting to the cloud. Okay? And that natural force of distribution is bound to happen. But of course, we have to build it out first.
So a question I have is where is IPv6 happening? Is it all around the world, and is there more V6 happening in some places than others? Maybe, Eric, you have some sense of that, or Lorenzo?
Well, we have statistics published on google.com/IPv6. You can look at our world map of which countries have been leading. Romania has pulled ahead recently. Bhutan. And France has been leading for a long time, actually. Yeah. The Free Telecom in France has done a tremendous job deploying IPv6 before we did. Actually, they were our first real source of V6 traffic.
Mm-hmm. So and that was the spark. When Google gave Quad A's, gave that IPv6 address advertisement in the DNS to Free, which at the time with a few 100,000 users was the largest commercial residential V6 deployment on the internet. When that Quad A went indiscriminately to those users on that network, right? And the traffic was there. That was the beginning of the network effect. That spark has then led to more and more and more and more. Now, not to say guys like John weren't working on this even before then, but that moment when the traffic started to flow, when you release those Quad A's and realize, wow, there's more than just like one or two university networks out there. There's like a few 100,000 people in France, and now there's, it's up into the millions, et cetera, right? But it was great to have witnessed that and see that happen.
2009, right? Early 2009. Yeah.
It's funny. I live in France, and I picked Free Telecom because of the IPv6, because of my coverage. I thought, hey, that's interesting. These guys went IPv6 way early. So I'm one of those people who can use it today. It's kind of fun to see it in action. But I wondered, maybe this is a good question for Comcast. Who are the laggards out there? Who are the bottlenecks? Who's dragging their feet? Comcast has been, working. Obviously, you guys have been working hard on this for several years. But how about your competitors, other ISPs? Who else needs to move here?
Stephen, I'm not going to name names. There are certainly people who have done their share to move the ball forward. We're very proud of the work that we've done over the past 7 years. I mean, I joke with, like I said, my friends and colleagues here. I mean, I've been doing this longer than, with the exception of Vint, of course, probably most everybody here on this chat. So There are a lot of people who've also been, who've come up and running as far as, folks who provide other types of broadband services, and they should be proud of themselves as well. I think you'll hear more about that over the next couple of days here. It's probably best to focus on that as the message.
Well, I'm sorry, I'm not trying to get you to point fingers at the duds out there, but I mean, has the ISP industry in general been moving fast enough? I mean, is that one of the choke points here in the transition? Do you think providing the customer premises equipment?
Let me let you off the hook. I will, John.
No, that's okay, Mark. That's all right. So the kicker here, Stephen, honestly, is if we look at the cable technology, we know what the state of readiness is for the cable technology. One of the areas that we're spending a lot of time on, in particular within Comcast, is the consumer electronics space. Myself, in particular, I do a lot of work with the consumer electronics vendors. I run a working group for the CEA, and we're really looking at that area now as really an opportunity that can help fuel the adoption and honestly the continued utilization of V6. I can't speak authoritatively as far as what the state of technology is for other types of service providers, but I can tell you that from a cable point of view, we obviously, because I'm doing it, we have the tools that we need to make V6 happen, and one of the things that we've come to the conclusion is we need to spend a little bit more time in the consumer electronics space.
So it strikes me, Vint again, that we really need to be able to track what's going on. I would invite people who are watching this broadcast to go to the www.isoc.org website and have a look at what they have to say about IPv6 and the launch and how well it's doing. But let me ask whether there is a place that people can go to sort of track how well IPv6 uptake is occurring. How much are we gaining on that? Maybe Eric or Lorenzo know the answer to that?
Yeah, we have. There are a couple of places. One of them is the google.com/IPv6 statistics page, where we have a graph of how IPv6 has been growing since, 2008? Yeah, so the last 4 years. And as Eric mentioned, our nifty world map. That world map also, to Stephen's earlier question, it also provides some information on regions in the world where there are significant problems deploying IPv6. For example, there's a very difficult situation in Japan at the moment. We expect will take many years to solve. Another one is if people want to look at statistics, there's the Akamai page, akamai.com/IPv6. Akamai powers a number of large websites, not Google, but a number of others, and there users can actually see the growth that has happened in IPv6 traffic on from the web server side. Those are the ones that I can think of.
Well, and
I'll throw another one. I'll throw another into.
Oh yes.
I'll throw another into the. Actually, Arbor Networks, which has a lot of partnerships with ISPs out there, they'll be watching this tomorrow. So if you want to watch that, you can go to ddos.arbornetworks.com. That's distributed denial of service.arbornetworks.com. Don't know why they picked that.
So actually, a suggestion, Stephen, actually to all of you, if it were possible to maintain a web page somewhere that has a list of all the places to go to where you can watch this stuff unfold, see some of the data and statistics. I think of CADA, for example, at UC San Diego would be another potential source of information, but it would be nice to point people to that. Eric, I sensed that you were about to add something after Lorenzo finished, and then we went over to Stephen. What was it you were saying?
Keep an eye on worldipv6launch.org, the ISOC website. As part of the criteria for success, and to make sure this was not just a paper event, we all agreed to be measured. Websites are being measured when we turn on Quad A's, and ISPs are being measured when, in terms of delivering users. So Facebook and Google and Yahoo and Bing are all contributing to the pot, our collective measurements of ISPs to see who's delivering how many users.
So I think we've pretty much run through the time that we had available for this little chat. Thank you all very, very much, not only for taking time in what could turn out to be a very busy day as we turn this thing on. For the rest of you, it's GMT midnight, June 6th, which for us here on the West Coast is 5 in the afternoon, not very many hours from now, for launch date and time. So I'm looking forward very much, of course, to see what happens, and we'll be encouraging everyone to keep tracking how we're doing. Those of you who are not yet IPv6 enabled, and if your ISPs are not ready, please ask them when they're going to be ready. That will help to stimulate a certain amount of progress, I think. So I wish you all great success today. I hope that it's a very placid launch and that nothing interesting happens, that no one notices, it just works, which is the way it should be. So thank you all. See you on the IPv6 network.
Thank you on the IPv6.
Bye for now.
Thank you.
All right.
See you, Vint. Thanks, guys. Take care.
Bye.